Hi friends, let us solve a nice problem. Here we have to find the sum of all four-digit positive integer palindromes. Right, positive integer palindromes which are of four digits. First, let's try to understand how many four-digit palindromes will be there. Palindromes, what are palindromes? For example, some number like 1001. That is a palindrome. Right, 1001 is a palindrome because from the right also from the left also it is it is the same, or 1221 or 2442, whatever, right? These are all palindromes. Now let us try to understand how many palindromes are there. Okay, let us understand all the palindromes starting with digit 1. Okay, all palindromes are 1. Okay, palindrome, four digit palindromes, right? First there are four slots. 4. So from the right and from the left, they should be same. That means the final digit also should be 1. Right. If it is starting with 1, the final also should start with should end with 1. Right. Now the second can be whatever. Let's say the second is 0. The third also should be 0. Right. That's then only it will become palindrome. Right. If the second is 1, then third also should be 1. Similarly, if the second is 2, third also should be 2. If the second is 3, third also should be 3. Right? So, for the second digit, we have 0 to 9 options. Right? Whatever the second digit is there, the third digit will become the same. So, basically, we have 0 to 9. That means 10 options. Right? 10 ways starting with 1. So, basically, starting with 1, there are 10 palindromes. Right. For example, 1001, 1111, 1221, like this. For example, 1001, 1111, 1221, 1331, 1441, like this. 1991. So, how many are these? 1012345678 9. Right. The second digit will be 0 to 9. So, there are 10 palindromes. Right. So similarly, every number will have 10 palindromes. So total how many? 90 palindromes. Because the first digit is 1 to 9. There is no 0. We cannot form a four-digit number with 0, right? 0 in the first place. So there will be 9 times. Each number is having 10 palindromes and 9 numbers in the thousands place. 1 1 to 9, because 0 cannot be taken. So total 90 palindromes are there. Very good. Okay. Now let us do one more thing. So 1001, 1111, these are all the palindromes that that are formed with 1. Let us look at the ones which are formed with 9. So 9, first number will be 9, last number also will be 9. Second can be 1, then third will be 1, second can be 2, third will be 2, second can be 3, likewise. Right. If you observe the first palindrome and the last palindrome, which is 9999, sum of what these two is what? So this is 1 less than 10,000. This is 1 more than 1,000. So it is the sum of this is 11,000, right? This plus this. This is 1 less than 10,000. This is 1 more than 1,000. If it was 10,000 and 1,000, it would have been 11,000. Now also it is 11,000. Right. Similarly, what is this? What is this? This is 111 more than 1,000. This is 111 less than 1,000. 10,000. Right. 111 less than 10,000. This is 111 more than 1,000. So the sum of these two is also 11,000. Similarly, sum of these two is also 11,000. You can observe. You can see. So likewise, sum of these two is also 11,000. Any one you take, so there is always a correspondence. So basically, what we have drawn, we have written all the palindromes from 1 to 1, starting with 1, then 2, then 3, then 4, then 5, 5 4 4 5, and 5 5 5 5, likewise. So from the backwards, if you write, there will always be corresponding palindrome 1 to 45 if you are writing. So then 46 to 50, 46 to 90. Remaining half of the palindromes, they will just add up with these ones to form 11,000. For example, the palindromes with 5. Right. 50, 05, 51, 15, 52, 25. Similarly, 54, 45. Next, 55, 55. These two together add up to 11,000. So, in this overall, we have 45 sets of 11,000 each. Right. 45 sets of the numbers which are totaling up to 11,000. Right. So, what is the total sum then? 45 into 11,000. Right. Right, 45 into 11,000, which is what 45 into 11 is 495, three zeros. This is the total. This is such a simple problem. Just that we should identify that sum of the first one and the last one, sum of the second one and second last one, sum of the third one and third last one. Right, these are adding up to 11,000, and we have 45 such pairs. Right, guys? This is a nice problem. Hope you like this. Thank you, guys.